Without energy from our sun, all remaining life in our solar system will disappear. However, this disaster could be preempted by accomplishing what so far has been impossible to do: actually duplicating the sun's hydrogen fusion right here on Earth. Science has already been able to manufacture nuclear fission, which involves the splitting of atoms into lighter, smaller nuclei. This is the power that drives our nuclear power plants and ignites nuclear weapons. But nuclear fusion, which occurs in the core of the sun, requires putting nuclei together to form a larger, heavier nucleus. And so far, this process has not been achieved here on Earth.
The problem with recreating the sun's conditions is essentially getting materials to the densities and temperatures that you have in the center of the sun. The sun has its gravity to drive the pressures and densities up so it can get these high reactions. On Earth, we don't have the luxury of using the sun's gravity, so we have to find other ways to try and compress the material and generate the kinds of densities that you see.
At the Lawrence Livermore National Laboratory in Northern California, scientists are taking on the challenge by attempting to create a miniature man-made star. The experiment involves aiming the world's largest laser, the size of 3 football fields, at a BB-sized target filled with hydrogen fuel.
In an inertial confinement experiment like the one at Lawrence Livermore, you start with a small pellet, maybe a half an inch across, the core of which is made of a solid material containing lots of hydrogen to undergo fusion, the outside of which has layers of different material that are engineered to produce a shock wave that will drive in and compress that core as much as possible.
The colossal laser will split into 192 separate beams that will strike the pellet housed inside a capsule. When the fuel pellet's shell is struck by these high-energy X-rays, it should implode and then ultimately produce nuclear fusion in its core.
If we had controlled, affordable nuclear fusion, it would change everything. Many things about our lives would change, but most importantly, we wouldn't need the sun anymore. We could produce energy, heat, light on demand. We could live anywhere in the cosmos with a supply of hydrogen and make our own energy. We could fly to other planets very quickly in days instead of years. You can extract all the water you need from practically any material that contains hydrogen and oxygen. If there isn't enough oxygen around, you could make some.
Generating reliable nuclear fusion could ultimately save Earth and all forms of life by eliminating our dependence on the sun. Yet the sun's own fate is forever sealed. As a white dwarf, it will become dimmer and cooler. The star that once provided energy to an entire solar system will eventually fade from sight.